Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on November 4th, 2025, about 2 days ago. The headline result is a tool-augmented evaluator that beats a vision language model, as judged by 0.41 F1, and when used to audit current generators, finds full compliance with detailed instructions tops out at 10%. The paper is titled LEGO-Eval, towards fine-grained evaluation on synthesizing 3D embodied environments with tool augmentation. And as we'll see later, the implications for model training are quite significant. Alright, Figure 1 contrasts reliable grounding with a failure case, showing why explicit tools matter for checking detailed constraints. Multi-hop grounding means reasoning through several steps, like first locating objects and then measuring how they relate. The left panel finds 2 pencils and computes their distance, so it can test the 1 meter claim. The right panel cannot localize the pencils, which blocks the distance check and yields an incorrect judgment. So Figure 2 shows an end-to-end evaluation pipeline that checks whether a detailed instruction matches a 3D scene. The process runs in 4 steps that move from constraint identification to final validation. A graph-structured plan means a tool schedule laid out as nodes and links, so multiple queries can execute in parallel. The left block plans which tools to call, the center executes them with precise arguments, and the bottom strip judges each constraint with short explanations. Okay, Figure 3 lists the toolkit that powers the evaluation, which means each constraint can be checked with targeted queries instead of vague prompts. The table divides tools into 3 groups so responsibilities are clear. Environment interaction tools capture views and spatial relations from the simulator. Textual reasoning tools pull structured lists and attributes like coordinates. Multimodal reasoning tools turn images into text descriptions, which helps verify appearances when raw pixels are ambiguous. So, Figure 3 listed the tools that make judgments possible. Table 1 compares evaluation methods on holistic and per constraint levels. The tool-augmented approach posts an F1 around 0.81, signaling balanced precision and recall. Cohen's kappa hits about 0.63, which means agreement with human raters beyond chance. Competing vision language judges hover near 0.40 F1, so they often miss ground components. Alright, Table 3 reports how 4 scene generators fare when judged against fine-grained instructions. Holistic success stays very low, topping out near 10%, which means almost no method satisfies every constraint in one go. Partial success looks better, averaging about 61%. So many single constraints pass even when the whole instruction does not. Floor layout is easy at roughly mid-90s, while object selection and placement remain the hardest pieces. Wrapping up, 2 takeaways stand out. A tool-augmented evaluator with explicit grounding reaches about 81% F1 and strong human agreement, and it exposes that current 3D scene generators fully satisfy detailed instructions only around 10% of the time. The broader implication is clear: fine-grained, tool-based evaluation will drive safer, more reliable embodied training. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.